Road to Olympiad.
Welcome to RTO. Consider the following problem. Let x and y be positive real numbers such that x times square root of 2 minus y squared plus y times square root of 2 minus x squared is equal to 2. Find the maximum possible value of x squared plus y squared. One straightforward observation may tell us that x and y are both equal to 1 is one of the solutions to these equations, thus giving us x squared plus y squared is equal to 2. However, we cannot make sure that this is the maximum. Today, we are going to show two solutions. The first one is nice and short and very useful in a lot of contexts. The second one is specifically dealing with problems involving square root like this one. Pause the video if you like to give this problem a try, and when you are ready, keep watching to learn how to solve it. To solve this problem, we start by noticing that we can modify the given expression on the left hand side into this one and then squaring it. So we can apply the Cauchy-Squash inequality to have the expression is less than or equal to this one. Notice that the left hand side is simply 2 squared, which is equal to 4. And the right hand side can also be simplified into this, which is equal to 2 times 2, which gives us again 4. This is to say that the equality holds in these situations, and for equality to hold in Cauchy-Squash inequality, we must have x over square root of 2 minus x squared is equal to square root of 2 minus y squared over y. Squaring both sides, cross multiplying, and simplifying again, we have 2x squared plus 2y squared is equal to 4, which gives us x squared plus y squared is equal to 2. And this marks the end of our first solutions. We can see that in these solutions, it is to tell us that regardless the value of x and y, we will always get one value only for x squared plus y squared, which is equal to 2. For the second solutions, we notice that x and y must be both between negative square root of 2 and positive square root of 2. So we can use trigonometric substitutions for x and y by letting x be square root of 2 sine alpha and y be equal to square root of 2 sine beta. Without loss of generality, we can further assume that alpha and beta are both acute angles. Then we can rewrite the given equation into this thing, where we can use the trigonometric identity to simplify square root of 2 minus 2 sine square beta into square root of 2 cosine beta, as well as square root of 2 minus 2 sine square alpha into square root of 2 cosine alpha. Multiplying the square root of 2, we have 2 sine alpha cosine beta plus 2 cosine alpha sine beta is equal to 2. Dividing by 2, we notice that the expression on the left hand side can be further simplified by the addition formula of sine, which gives us sine alpha plus beta is equal to 1. And since alpha and beta are both acute, this implies that alpha plus beta must be equal to 90 degrees. Substituting beta is equal to 90 minus alpha, we have y is equal to square root of 2 sine 90 minus alpha, which is equal to square root of 2 cosine alpha. And thus, x squared plus y squared simply gives us 2 sine square alpha plus 2 cosine square alpha, where again we can apply the trigonometric identity sine square alpha plus cosine square alpha is equal to 1 to obtain 2. And this marks the end of our second solutions. Post in the comment below if you have any thoughts on the video, and if you haven't subscribed yet, consider subscribing. This will really help us out. Anyway, see you in the next video. Thank you.